Today's lesson is on deductive reasoning. By the end of this lesson, you should be able to differentiate between inductive and deductive reasoning, apply deductive reasoning to make valid conclusions, apply contrapositive reasoning to make valid conclusions, apply chain reasoning to make valid conclusions, and determine whether or not it is possible to make a valid conclusion from given information. Lastly, we will make sure that we can find errors in reasoning made by others that might not follow the laws of logic. So we have been studying inductive reasoning up to now, and now we're going to learn about the difference between inductive and deductive reasoning. So as a reminder, inductive reasoning is when we make inferences based on patterns. So in this example, 1, 2, 4, we can guess what the pattern is and see if we can continue the pattern. So we might guess +1, +2, well, I think the pattern is that we're going to now add 3 to get 7, and then add 4 to get 11. And I can justify this pattern based on the 3 first terms that I'm given. So that's inductive reasoning. The problem is that might not be the pattern that the writer intended. Perhaps the pattern was 1, 2, 4, and instead I'm doing times 2, times 2, times 2. The next one should be 8, and then 16, and then 32, etc. So inductive reasoning is very useful, and it helps us to come up with good conjectures. But then we need to test those conjectures and see if they must hold under all conditions. And that's where deductive reasoning comes in. Deductive reasoning is making conclusions based on facts and using the laws of logic that we're going to learn about right now. So we prove one fact knowing another fact, and that is really how geometry was created, is starting with a list of certain facts and proving other things based on those facts. So our goal at the end of this unit is to have all of the tools ready so that we can start proving things in geometry. And to prove things, we need these laws of logic. We need this deductive reasoning structure. So just 2 more quick examples to illustrate the difference between deductive and inductive reasoning. In Framingham, April has been the rainiest month for the last 5 years. Tamara concludes that April will be the rainiest month this year as well. Well, Tamara didn't have any rules saying that April is always the rainiest month of the year. She looked at the last 5 years and decided that based on the pattern that she should conclude that this year April will also be the rainiest month of the year. Anytime someone uses a pattern to make a conjecture, we know that they are using inductive reasoning, because inductive reasoning is making a conjecture based on a pattern. In example 2, we have a library charging 20 cents a day every day that the book is overdue. Miss Treitman, that's me, concludes that when she returns her daughter's overdue book 3 days late, she will owe 60 cents. So when I'm making that conclusion, I'm basing it on a rule or a fact that I know to be true. So this is a known, true fact. I know that the library charges 20 cents a day when a book is overdue. Because I know that fact, my conclusion is based on that fact, and therefore I am using deductive reasoning. So now that we know the basic differences between inductive and deductive reasoning, we're going to learn 3 laws of logic. The first law we're going to learn is called the law of detachment, or in Latin, modus ponens. We're going to refer to it as direct reasoning. So in direct reasoning, we make a conclusion from a conditional statement. In this example, if you earn a 59.5% or above in a course, then you will get credit for the course. This is a known true fact. You then earn a 72% in the course. This is also a known true fact. The question is, what can you conclude? Well, you can conclude that you will pass the course, that you will earn credit for the course. So I know that you make these conclusions all the time, but this has a formal structure in logic. Direct reasoning has the following form. If we know that the conditional statement, if P then Q, is true, and we know that P is true, we can conclude that Q is true. The general form is often made using this notation, sometimes written P implies Q, P, two given facts, therefore, that little 3 dots and a triangle symbol is called therefore, we can conclude that Q is true. So sometimes it's written in this first way, sometimes it's written in this second way. They are the same. They are both the form for direct reasoning. Here's another quick example of something to be careful of when using direct reasoning. In this example, we have a conditional statement. If two angles are vertical, then the angles are congruent. So our P is two angles are vertical. Our Q is that the angles are congruent. Now we're given a second statement. Angle A is congruent to angle B. So the question is, what are we given, P or Q? Well, if we're not careful, we might accidentally think that we're given the form P implies Q, P, therefore Q. But actually, we're not. This is Q. So do we have a rule that says P implies Q, Q therefore something? No, we don't. And in fact, we can give a counterexample here. If two angles are vertical, they are congruent. Well, we know that that's true. But if two angles are congruent, must we conclude they're vertical? Certainly not. I could draw two 90-degree angles like this. And those two angles are congruent, but they're certainly not vertical angles. So this is a counterexample, and just be careful of this form. Sometimes you'll see conclusions based on invalid forms of reasoning. So we cannot make conclusions based on invalid forms of reasoning. This next example is called contrapositive reasoning, otherwise known as modus tollens. Now, this form of reasoning isn't in your book, but I did want to touch on it because I think people use it a lot, and I wanted you to see an example. So the example here is, if you want to visit the Rock of Gibraltar from Spain, you need your passport. I know this to be true because not Laura, but I was in this situation. You do, in fact, need your passport. It is not part of the EU. Laura, in this case, does not have her passport. What can we conclude? Well, I can tell you from experience that they will not let you in. So that is the conclusion. They will not let you into Gibraltar without your passport. This form of reasoning has the following form. If P then Q is true, in other words, if we have a true conditional, and then we know that Q is not true, then we can conclude P is also not true. We also see it written in this form. We have a conditional P implies Q. We know that Q is false. We can include that P is also false. And just a little star, remember that the conditional and contrapositive are logically equivalent. And that's why the law of contrapositive reasoning works, because really it uses the same idea as direct reasoning, but it uses the contrapositive of the particular conditional statement. The last form of reasoning we're going to call chain reasoning. And this logic law is often called the law of syllogism. That is what your book will call it. But we like to think of it as a chain because really we're lining up statements, conditional statements, in a chain to make conclusions. You can almost think of it as lining up dominoes, where one chain has to match the link of the next chain. And I'll show you in this example how that works. So in our first example, we have, if you babysit this weekend, you will earn $50. So our hypothesis is you babysit this weekend, and our conclusion is you will earn $50. Now, notice in our next conditional, if you earn $50, then you can afford a new video game. Well, you earn $50 has already been assigned a letter. That's Q. So this new statement, you can afford a new video game, we're going to have to assign a new letter. I'm going to call it R. So we have this form, P implies Q, then we have another statement, Q implies R. Well, I can conclude here that if I babysit, I will be able to afford the new video game. And what we require in this form of reasoning is that the conclusion of the first conditional is the hypothesis of the second. This must match this, so that we can almost line them up. You can imagine if we put it up here, Q implies R as dominoes. These pieces need to match. The conclusion then is that this P implies this R, because if we start with P, we end up with R. So now we have learned 3 logic laws: direct reasoning, contrapositive reasoning, and chain reasoning. We are going to now see some examples where we need to use one of these forms of valid reasoning to make a valid conclusion. And it is really important to understand that in order to make a valid conclusion, you must use a valid form of reasoning. So as I'm trying to figure out which rule to use, I'm going to label what kind of statements I have. In our first example, if you get a job, you will earn money. I'm going to call this P and this Q. If you earn money, then you can buy a car. Well, you earn money has already been taken. That's Q. It already has a letter. You can buy a car is new. That's R. Well, this follows the pattern, the chain logic law. If P implies Q and Q implies R, I can conclude that P implies R. In other words, I can conclude that if you get a job, then you can buy a car. This is using chain reasoning. In our second example, we have if a figure is a square, then it has 4 right angles. So I'm going to label a figure is a square as P, and the figure has 4 right angles as Q. We are now told that figure R has 4 right angles. Well, has 4 right angles already has a letter label. It's Q. The question is Leon allowed to conclude that figure R is a square? In other words, if I have P implies Q, and then I have Q given to me as true, can I conclude P? And the answer is no. In fact, the figure could be a rectangle. We cannot conclude that the figure is a square. This is not allowed. So no, he accidentally thought that he could use direct reasoning, but he cannot. So we've now talked about all of our objectives. It's time to go back through and make sure that you understand each one of these topics. If you don't understand any of them, please star the objective so that we can go over it in class tomorrow. The first objective was to differentiate between inductive and deductive reasoning. The second was to apply direct, contrapositive, and chain reasoning to make valid conclusions, and also to determine whether or not it is possible to make a valid conclusion given particular information. Lastly, it was our goal to find errors in reasoning made by others, and we just found one made by Leon in the previous example. So now it's time for you to try some on your own. Okay, here are your practice problems. Don't forget to label the problems, and good luck. I'll see you tomorrow.